We humans consider ourselves as the most evolved species on Earth, as we are far more developed than other creatures in many aspects. However, what we might not know is that our vision system is considerably mediocre when compared to other animals. In fact, our eyes have 3 different receptor cones that detect colors in red, green, and blue. While other animals, they have eyes that are completely different, and even sometimes more advanced than ours. Some of them, they can even see in different spectrum as shown here in the chart. Focusing on infrared, certain species of snakes have the ability to see in thermal spectrum, which enables them to see perfectly in total darkness. Also mosquitoes, and that's how they get us at night even under the bed sheets, as they just detect the heat emitted by our bodies. Well, thermal imagery is not only useful to see in darkness, it also enables us to see under challenging scenarios in which most probably the human eye fails. So, the motivation of my PhD is to extend the human vision capacity to be able to see in thermal spectrum. But don't get me wrong, I'm not gonna be playing around with human eyeballs or any of this kind, no. Well, let's be realistic. We all know that computer vision systems and display devices are widely spread everywhere now. But, being humans as we are, we've developed them to operate exclusively on RGB data, which we can perfectly see and understand. So, my efforts are dedicated to use the thermal information in a way that can be understandable by humans, and also by these existing computer vision systems. And that is by using this information to estimate how we would see in visible domain. To do so, I'm basing my research work on deep generative models to learn a mapping between visible and thermal spectrum in order to be able to synthesize a visible scene from a thermal input. Training these models requires a paired database acquired simultaneously in visible and in thermal spectrum, which I've managed to collect one of its kind using the dual sensor camera by FLIR. Also, training these models aims to minimize a loss function designed for a specific task. My research work was initially focused on face recognition application, but then it quickly caught the attention of fire brigade forces, as they are interested in using thermal imagery to see through smoke, gas, dust, situations in which firefighters find themselves very often. So my work, along with the fire brigade forces, consists on developing some automatic algorithms to detect people and monitor their health state in risky environments, and that is to ensure the safety of both citizens and firefighters. Also, my work aims to translate the scene from thermal spectrum to visible for when human intervention or analysis is required.